Hello, Assalamu alaikum everyone. I sincerely hope that you're all healthy and safe and are taking care of each other, your loved ones, your family and friends. So, we have been asked, faculty members at the Mechanical Engineering Department, to um, make every effort we can to continue the learning process for the final year student and continue to deliver what we can through online means for final year students, all the subjects uh, that are possibly achievable through online means. So as you know, I have the maintenance engineering module with you, and since it's mostly a theoretical subject, I feel we can learn as much from this online process, online learning, as we would in the classroom. Of course, it would not be completely as effective, uh, but these are challenging times, and we will all have to work together and support each other and learn the best we can from the resources available. So we have put together the interface of Google Classroom, and I'm sure you've all have been invited to take part in maintenance engineering module through Google Classroom. So what I see from my end on Google Classroom is something like this, and I upload all the relevant material that is of your concern in order to enhance your learning process, apart from the lecture series that I will mostly be recording and uploading under the lecture materials. So you will find under lecture materials the slides that I use, as well as the voice recording that I use to explain and elaborate the slides as a lecture. And the reason I do that is because, of course, I am trying to give you the luxury to go through this lecture whenever it is convenient for you. So what I would like to do in this lecture is ready to recap on where we left. So we did few lectures on maintenance before the coronavirus situation, and the idea would be to first of all gather our understanding on what we discussed before the break and make further progress from there onwards. I have to admit that the quality of this lecture in terms of clarity and efficiency may not be effective, because I have not done this before, and I am doing this obviously from my residence, and I can't have complete silence in the background, so you may hear some background noise. So do apologize for not giving you the best quality here. And of course, you have the option of sending me your questions through email if you have any doubts or not clear on any of the discussion points, since this is not live interaction. So yeah, let's just get through things. So welcome everyone, and welcome to Maintenance Engineering. As I said, we all are aware these are challenging times, and we will now make every effort possible to adopt to this new method of learning until further notice. And we ought to do this by supporting each other and understanding each other in the best way. Of course, we are doing this because health and safety is most important to us, and we will keep that in mind. And until we have clear notice from the authorities that it's safe to proceed to live interaction, we will of course do so. But until then, we will try to adopt this approach. So having said that, I will move on to the recap part. Right, so maintenance engineering, as we picked up, and we'd all agreed that as engineers, we need to really understand what maintenance engineering really means. And we agreed so far in our previous discussion that as engineers, we design systems. Everything for us that we would ever do as engineers would be dealing with systems, whether it's cars, rockets, airplanes, printers, laptops, you name it. Products for us are systems. We have, as engineers, there is no such thing as products. We deal with systems. So the idea really is in maintenance engineering is to deal with those systems, right? And what are we aiming for really is we maintain their functionality. So when we design systems, we design systems for a specific purpose. That purpose is a function, is fulfilled through engineering as a function. For example, car takes us from point A to point B. That's the purpose of the car. That's the function of the car. So we have systems. Systems are nothing but fulfilling functions, right? They are built for a specific functionality. And through maintenance, what we are trying to do is targeting maximization of this functionality. So we want to basically maximize the function as such so that it remains at its best. So we are trying to maintain the system as such that it stays at its best functionality. And so therefore we can target for maximum utilization of that system, which can lead us to maximum profitability of that system. And also, of course, in this process, what we want to ensure is that the system we deal with is worth maintaining as well. So it's got to be a system that is of worth of high value, right? The cost benefit of maintenance has to be balanced. It has to be worth the investment to maintain that system. So in essence, as engineers, we have systems. Systems have functionalities that we want to keep at its best so that we can have maximum utilization and profitability. But we want to do this only on systems that prove are worthy of investing maintenance in, right? For which we need to understand the overall investment portfolio. So we need to understand the magnitude of investment. And this can only be done by figuring out for a given system what's the best way to maintain it. Right? How you maintain a car is different from how you maintain, for example, a fighter jet. And how you would want to maintain a fighter jet would be different from how you maintain, for example, a rocket. Right? How you maintain, for example, your laptop is different from how you maintain your house, for example. Right? How you maintain your watch is different from how you maintain your clothes. So the key thing here to understand is it's got to be a worthy asset. We got to be able to identify that system as high value asset. To start thinking about is maintenance worth and maintenance strategy. Right? So from where we left, we agreed we deal with systems. We deal with functionality of the system. We want to keep this functionality at its best. We will only do it if it proves value for that system, if it proves the investment for the system. And we will do it as such that it minimizes the cost by having the best suitable approach. So what would be the best maintenance approach that will give me maximization of utilization and profitability? Okay. So moving on, we have this sort of horizontal view at the moment, right, of maintenance engineering. We deal with system. That's everything for us. Right? As engineers, we deal with systems. In systems, we build functionalities. Everything is designed to do something. There's a purpose behind it. And that's what we're targeting. We're targeting value from maintaining that purpose. We want to sustain that purpose. We want to sustain that functionality. Every function is related to its faults. So this function corresponds to a system. That system is comprising of multiple subsystems of subsystems. The overall functionality, therefore, is multidisciplinary or interdisciplinary. A car function is take us from A to B, but it does that by fulfilling multiple functions of its subsystems: tires, brakes, fuel system, engine, chassis. All these functions of subsystems come together to support the overall functionality of the system. We want to sustain that functionality at its best by minimizing and dealing with the faults that may arise from different system, subsystem and components of that system. And so to do that, we need to understand the overall hierarchy of the system, subsystem component, their possible fault modes. So how many ways a tire can, for example, what can go wrong with a tire? It can get puncture, for example. It can get friction, and due to that friction, its surface can get degraded. It can get slippery. So all those fault modes we want to think about for all these system, subsystem components that can affect this overall functionality. By doing that, we are targeting maximum utilization. And we do this by balancing the cost and benefit. for addressing those faults. We make our system more reliable by addressing the faults. We make our system therefore more, less prone to faults. If it's less prone to faults, then it will be more available, it will be more healthy, right? It will be available to perform the functionality when we address the faults. And by addressing the faults, what we are doing is we are building a maintainability function for the system. And we do this reliability, availability, and maintainability function by using the best approach that balances all these three things. So in essence, system, the overall hierarchy of system, the functionality, the overall functionality, and how it's supported by subsystem level functionality. What are all the possible faults that can go wrong with the overall hierarchy, and building a strategy to address those faults in such a manner that it provides us with higher reliability and confidence, allows our system to be available, and we have a proved way of maintaining our system, a validated way of maintaining our system through a best approach. Once we have that, we achieve at the end safety, because we have addressed all the faults. We understand the system as to in how many ways it can fail at subsystem and component level. So we have appropriate diagnostics, for example, in place, and appropriate measures in place for all these possible fault modes. So therefore, I am preventing my system to lead to a situation that can compromise the safety. But at the same time, I am maximizing the performance by minimizing faults. So therefore, I can use my system for the purpose it's designed for, which gives me utilization, and that gives me profitability as a, for example, enterprise. So minimization of maintenance costs to maximize profit, and by understanding the system failures, we increase its safety. So that's the kind of horizontal outlook for the concept behind maintenance engineering. Why would I even bother looking into maintenance engineering? What's the ideology behind it? And it's the fact that we build systems, we build them for a purpose. Most of the systems we build are rather complex in nature. They are not straightforward one system. They comprise and depend on functionality of multiple subsystems. They are integrated and connected and designed as such that they work together to fulfill an overall purpose function. And so therefore, they, by the very nature of mechanical designs and electrical components within the system, they are prone to faults, and those faults are leading to system functionality failures, which can affect the availability of the system, and therefore its availability and utilization. Okay. So I want to achieve maximum safety and maximum profitability from my system. And one way to do this is by paying attention to how I can well maintain it. Right? Now, of course, we will move on and break this down into objectives, principles, and explore various different approaches in general that are available for maintaining different systems. So these two slides are now available on the lecture material. You can access those in your own time. Now I want to move on to a bit more detail of background. So exploring the more of an basic principles and objectives and motivations behind maintenance in general. So we want to understand the principal functions and practices adopted in industry for successful management maintenance activities. We by the end of this lecture, you should be able to explain maintenance categories, what are different types of maintenance, and you'll be able to illustrate some simple instrument used for condition monitoring in the industry. By the end of this module, you'll be able to understand maintenance functions. You'll be able to perhaps introduce and implement maintenance functions, identify maintenance functions in industries, and sort of like what would be the right way of management approach to maintenance. And very clearly distinguish between different approaches available for dealing with systems maintenance. So, just to recap, maintenance is all about machine or an equipment restore its state at which it can perform required function. So it's dealing with the function, maintaining that function, retain the function of a machine or equipment or whatever. Mostly it's for us a system. It's indeed a dedicated field of engineering. Because we want to achieve the best way of maintaining a function, we need to optimize things. We need to address the conflicting requirements between different systems. And what we are really looking for is reliability, availability, and maintainability, right? That's in the best way possible. So it is, of course, part of art and science and philosophy. It includes human factors, which covers the philosophy part. It includes mathematics, so that's where the science comes in. It includes the art, which is really about the mindset of an organization. You got to have firm belief in doing things the right way, doing things systematically. That's where art and philosophy comes in. And because we deal with reliability is all probabilities. Availability is a function of a given probability, right? And that's mostly related with science. And the very basic nature of system design is that we solve physics and chemistry in systems. So car has an engine has a burning need to burn fuel, and that demands the composition of chemical equilibriums in the combustion chamber and piston designs and so on and so forth. So we deal with science, art, and philosophy in maintenance. So all actions that are necessary. So these actions are nothing but all the approaches that we take and feel as necessary to retaining an item, restoring to its serviceable condition, including servicing, repair. So all these things are basically actions of maintenance: repair, modification, overhaul, inspection, condition verification. You will repair something upon, for example, an approach of corrective maintenance. So my laptop screen breaks and I repair it. Modification would be I modify the properties of the screen glass as such that it is much more robust to failure. Overhaul is I have a complete major overhaul of the memory card, the processor, the keyboard, the screen. So we have a complete overhaul. Inspection is where we mostly take in regular inspections, cleaning the screen regularly, or we may be doing some sort of screening of the screen for cracks or potential faults. Condition verification is more like I have some sort of mean of measuring the condition of the screen in real time. So if any fault occurs, I am aware of the fault. So this is more like in condition-based maintenance. And we basically all we want to do is maximize the availability of the system. Okay, because we want to be able to make the system available for its function, to be utilized for its function. Availability do not prove any benefit for business, for example. For PIA, what really matters is they can utilize the aircraft. Having the aircraft available is of no use. Right? However, in maintenance, the job of an engineer is to make the aircraft available. It's up to the operations team and it's up to the team of sales team to bring customers so that we can utilize the aircraft and make money out of it. Right? The engineer job is to make it available. Okay, which is why there is no utilization here. What we are trying to do is to maximize availability of the system. Excuse me. So we want to keep systems equipment in working order, and that's the main role of maintenance engineering. We want to keep the system in functional order. There is no such thing as working, right? We want to use the system availability because we want to keep it functional. Like, it goes back to the same point. Why we want to do this? Because we want to minimize our business risk, right? If I design a system, I'm going to effectively sell that system to a business, right? Like, for example, the Boeing company, they design aircrafts. Aircrafts are nothing but systems, right? They take people from one point to another point. They have to sell this aircraft to an airline one day. Right? So all the airline wants is to minimize their risk to have the aircraft failed while it is parked at an airport gate with 200 people on board. Right? Airline wants their airplanes to be functional as much as they can. So it minimizes the business risk. Right? So the whole reason of doing maintenance is to minimize business risk. In industries, for example, when you're manufacturing, for example, could be anything, maybe commodity products like the juices, milk or cream, or things like toys for kids. In factories, you have agriculture factories. The production lines is to maximize production capacity. I don't want to have any failures in my production line, because if I have a failure, the production line will go down, so I cannot produce as much. It's about building capacity as well, being more productive, gaining more profits. And how do we support that? Is by configuring, diagnosing, repairing, upgrading throughout the life cycle. When you, for example, where does the life start for a system? The life starts for a system, but really from the mind, because you conceive an idea. Right? That's where the life starts. You then convert that idea into a product, or into a shape sort of thing, which you draw it into a drawing, and you build systems around it, build a functionality around it, and then you build that system. Wouldn't it be very nice when we build the system, we know about all the ways, all the possible ways it can fail, so we can provide and configure and provide diagnostics for all the failures in the system. But it doesn't end there, because we have what we call surprises, right? Unforeseen surprises, or unscheduled or unexpected failures. So we need to manage the system throughout its life cycle, which is its conception, its design, its production, its operations, and then when it comes, its end of life. So configuring, diagnosing, repairing, and updating the equipment, the system as such, that we do this sustainably throughout its life cycle. Remember when we defined maintenance, we said maintain is to maintain or support or keep fixed. Nuns is about sustaining it throughout its life cycle. So maintaining the equipment at its full functionality and helping productivity, the main functions, maintenance engineering, attempt to maximize performance, equipment efficiency, prevent breakdowns, minimize production loss, increase reliability of the system. Of course, we are as engineers, we are in the fourth industrial revolution. Okay. How maintenance used to be 20 years ago, 30 years ago, or even in the first industrial revolution is different from how maintenance is today. Right? We have increased complexity increased automation in systems. We have very sophisticated control systems in more systems. So of course, this is a significant challenge for engineers today to implement efficient and effective maintenance strategies to better manage the functionality throughout the life cycle. We therefore need proactive efforts in exploring innovative ways of maintaining modern systems. One discussion, for example, is about, let's say, maintaining a PIA aircraft, right? Now, there's a very conventional way of doing maintenance on a PIA aircraft. An aircraft fault occurs, that fault is reported, and then the reported fault is diagnosed, and then diagnosed fault is repaired, and once the repair is done, it is approved and qualified, and then the aircraft is sent back, and then it comes to an availability form again. What if we want, for example, a solution where we know in advance what will go wrong with, for example, the fuel pump on the aircraft, or what will go wrong with the engine on the aircraft, or what will go wrong with the landing gear of the aircraft. We have prior knowledge, we have advanced knowledge of what will happen to the aircraft after 1,000 flying hours. So we can then plan and maintain the aircraft optimally and in a most efficient manner. But that requires thinking beyond the existing methods available and thinking about how we can move to this new era of maintenance revolution. Okay. So objectives are to achieve product quality, customer satisfaction. If I, as an aircraft manufacturer, design a reliable and highly available and maintainable aircraft, my airline as a customer will be satisfied, right? There's something called maintenance credits in the airline industry. Plays a huge role in customer satisfaction. Like, I sell an aircraft to an airline and I give them 1,000 maintenance credits, which means I am responsible for maintaining your aircraft and making it available in this time frame 1,000 times throughout its life cycle, which gives them higher confidence in purchasing the product. Maximize useful life. We want to maximize the utilization. Useful life is nothing but utilized life, right? That can only be done by having the system available. And I would encourage you to not use word equipment, although I have used it here, but it's more of a maximize useful life of systems. Keep systems safe and prevent from hazards by understanding the fault modes. If we do a best maintenance strategy, what are we doing? We understand all the possible ways through which our system, subsystems, components can fail. And this knowledge allows us to minimize hazards and enhance safety. Minimize frequency and severity of interruptions. So once we understand these faults, maybe we are able to, once we have the full knowledge of these faults, maybe we can do something that can enhance the performance of these subsystems and components to be less prone to faults. So if a fault in the bearing occurs, let's say if a fault in the gearbox bearing occurs after 1,000 hours of operation of 60,000 RPM, what I can do is maybe I can look into the material properties of that bearing and enhance it to not be prone to crack after 1,000 hours. So I can minimize the frequency at which the fault occurs. Or I can minimize the severity. So the crack length is after 1,000 hours or 6,000 RPM is 2 centimeter. Maybe I can bring it down to 1 centimeter by enhancing the material properties. So that's what I mean by frequency of faults and severity of faults, right? Because you have to keep in mind, having a crack is a fault, right? Having a crack in the bearing is a fault, but it does not necessarily mean that the bearing will stop working, right? A fault is not a failure. Fault severity leads to failure, right? So for that given bearing, if the crack goes beyond 10 centimeter, for example, it will lead to cause a failure in the bearing. It will maybe lead to a rupture of the bearing, which will then create significant vibrations and make the system fail. The bearing will not be able to keep its balance RPM anymore, its functionality. So it basically leads to failure, right? And in industries, the manufacturing industries, we are looking at maximization, production capacity, high utilization, so of the facility and so forth. Just to give you, because I've done some work in the aerospace industry, just the commercial aviation, not thinking about military aircraft or anything, just planes that passengers use. The maintenance, repair and overhaul industry for civil aircraft is multi-billion dollars are spent every year on maintaining the aircraft for passenger travel. So it's a huge industry. If you think about it, the aircraft have over thousands of subsystems, and all those subsystems must be maintained to fulfill the overall functionality of the aircraft. So we're dealing with a major industry for maintenance. Okay? And just like aviation, all the other industries are significantly maintenance driven. Thinking about, for example, automotive, heavy maintenance. All industries are, of course, maintenance driven. Think about the ships and submarines, all maintenance driven. The only industry I know of that is least maintenance effective is the satellites, right? You got to have 100% perfect satellite. If you want the satellite to work for example, 10 years, you have to make 100% sure on the ground before launching it that it will survive 10 years in the space. Because you just cannot afford to go up in the space and repair it. That's the only one industry I know, space industry, that is different in terms of maintenance from all other industries. But the message is, maintenance is a big industry. Some more figures there for you. It's not just commercial, it's military as well. Wherever there are systems, there is maintenance. But the only system I'm aware of is maintenance free when it's designed and deployed is satellite. So that's what I wanted to cover for today. And Of course, usually in a one-to-one class interaction, we would go into discussions, and we will discuss different points in more detail and explore understanding, which we are not able to do so here. But please feel free to send me your email questions in the email, but of course only questions that are compelling for your understanding. I don't want my inbox to be loaded with trivial questions. Okay. So that's all I want to discuss on today, from where we left. Just to have a recap and look into some basic fundamentals of maintenance engineering. So all these slides are available on the Google, as you can see here. Lecture 1, Lecture 2. This is the slides we just went through, and in here, this refresher, Lecture 1, Lecture 2 refresher, is what I went through with you in the earlier phase of the lecture. And assignments, I have put together an assignment for you, which is, I want you to look at assignment ME1. Sorry, I uploaded an assignment earlier on, so let me just refresh that. So there is an assignment which is due on 15th of May, and it's to explain the importance and purpose of maintenance engineering in general, keeping in mind you're an engineer, you design systems, and why would we want to do this? Explain the image below in the context of maintenance engineering. So just like I have expanded on this, I want you to give me your understanding of what you think this is, and explain the objectives and principles of maintenance. For assignments, the way you submit this is you write this in a Word document. You save the file as your roll number and name. You save the file as PDF. You email the file to your CR, and the CR will send me all the emails in a folder, all the assignments in a folder. Okay, so I don't want you to send me your assignment through email. I want you to send a PDF file of your assignment file to Ghayur or Ibrahim, and they will forward it on to me in a complete folder, and they will not accept anything beyond 15th of May. Okay. So that is all I wanted to cover. I hope you take advantage of this, and if you have any questions, do let me know, and inshallah we'll make further progress accordingly. So take care, stay safe, have a good Ramadan, and I'll speak to you next time. Allah Hafiz.